Hi everyone, this is Mrs. G.A. and today we're going to be solving rational equations. Alright, I have a quick warm-up for you guys, so if you could pause the video and give these a try, you could hit play when you're ready to check your answers. Alright, go ahead and check your work here. So for part A, if you find the least common denominator of 3, 4, 6, and 4, that's 12. So if you multiply the numerator and denominator by 12 and you distribute, it cancels out the fractions within your numerator and denominator, and you're just left with 4x plus 15 over 4 minus 9x. Here, there's nothing you can do to simplify that, so that means you're done, and your only restriction is that x cannot equal 4 over 9. And for part B, you do need to factor everything. And then from here, anything that's in your denominators, so here and here, or this, because when you multiply by the reciprocal, it becomes a denominator, those will give you excluded values. X squared plus x plus 1, although it's in a denominator, if you set it equal to 0 to find excluded values, you'll find that they're imaginary, so we don't need to include them. And then here we're just multiplying by the reciprocal of our bottom fraction. So our denominator gets multiplied all the way to our numerator. So those end up here. And then these two get multiplied and end up in your denominator. Again, this is just multiplying by the reciprocal of the second fraction. And then after you cancel out common denominator or common factors, you end up with this. So just be careful with these problems for your excluded values. Anything that is ever in a denominator needs to be included. Okay, so now we're going to be solving rational equations. So there's a few different methods that we can use depending on the problem. One thing we are always going to look for from the beginning is excluded values. So before we do anything else, well, we're always going to factor first, and then we're going to list our excluded values. So once we start solving, we know that we can check for what are called extraneous solutions. So solutions that we get algebraically but don't work because of the excluded values. So if we factor everything, here's what we got. So from the beginning, again, list your excluded values. X cannot equal 5. So as we're solving, as long as x is not 5, the answer is valid. So when you have a single rational expression equal to a single rational expression, you can actually solve this by just cross-multiplying. So something that you probably learned to do a long time ago when you just started working with rational equations, maybe in Algebra 1. So 3x plus 7 times 2 times x minus 5 equals 5x plus 17 times x minus 5. So now you don't have a rational equation, but we may have a quadratic equation. So now we just have to multiply everything out. So I'm going to multiply the 2. I'm going to distribute it here, and then I'm going to multiply these two binomials. So this gives us 6x squared, and then we have minus 30x plus 14x, so minus 16x minus 70, and then on the right we have 5x squared, and then we have minus 25x plus 17x, so minus 8x, and then minus 85. So we have a quadratic equation, so let's set it equal to 0. So we get x squared minus 8x plus 15 equals 0. So this we can solve by factoring. So x minus 5 times x minus 3 equals 0. So here we get x equals positive 5 and positive 3. So here's where it's really important that we have listed our excluded values, because when we're solving, x can be anything except for 5. So here, this x equals 5, we're going to exclude that. This is called an extraneous solution. So again, algebraically, yes, this is what we got, but it doesn't work for this equation because of our excluded value. So we have one answer to this equation, and it is x equals 3. All right, so let's try another one together. So for this problem, we don't have a single expression equal to a single expression, so we can't cross multiply when it's in this form. So I have a different approach for these types of problems, and I think it's definitely the easiest way to go for these types of problems. We're just going to clear our fractions by multiplying by the LCD. So we multiply both sides by the LCD, and then you'll no longer have a rational equation. It might be a quadratic equation or some other type of equation that you can solve, but it will not be rational. So if you look at your denominators, we see that we have x minus 7, 2, and x minus 7. So in this case, our LCD is 2 times x minus 7. So I'm going to multiply both sides of our equation by that full LCD. And when I'm doing that, I would need to distribute. So every single term gets multiplied by 2 times x minus 7. And I like to sometimes write it out next to each term so it's easier to look for common factors. So in this first one, x minus 7 cancels out, and I have 2 times 2x minus 9. Here, 2 cancels out, so I'm left with x times x minus 7. And then here, x minus 7 is a common factor, so I'm just left with 10. So you can see that in one step, it's already a much easier equation for us to solve. But something I should have done from the very first step, but we can do it right now. So we should list those excluded values. So from our original denominators, we can see that the only excluded value is that x cannot equal 7. So as long as our answer isn't 7, we are good to go. So now we're just going to distribute and see what we're working with. So here we have 4x minus 18 plus x squared minus 7x equals 10. So you can see we have a quadratic equation. So we'll set our equation equal to 0. And this quadratic we can solve by factoring. So x minus 7 times x plus 4 equals 0. So we get x equals 7 or negative 4. But again, checking for our excluded values, we see that x cannot equal 7. So again, we have an extraneous solution. So it is not part of our final answer. So our only answer is x equals negative 4. All right, I'm going to ask you to pause the video and give this problem a try on your own, and we will check your answers in just a few moments. All right, so if you check your work here, I would factor first. And then you can list your excluded values, so x cannot equal 0 or negative 2. The LCD of this equation is x times x plus 2, so if you multiply every term by that, your fractions disappear, and then you're just solving. So this one, it's actually, it ends up being a linear equation after your x squared terms disappear, so you just get one solution, x equals negative 1, and as long as it's not one of our excluded values, which it's not, we're good to go. All right, so now we're going to try a couple of rational equation word problems. So for this first one, it says Mrs. G.A. is kayaking. She's traveling 5 miles upstream. I'm going to highlight that. And then the 5 miles back downstream, so it's the same distance for the trip in a total of 6 hours. In still water, her average speed is 3 miles per hour. What is the average speed of the river's current? So for these types of problems, it's important to understand like what's the difference between like her speed in still water and then the speed of the current. So the idea is if the current is headed, let's say this way. So if the kayaker is going downstream, when she's going downstream, she's going to be going a little bit faster, right? Because there's the speed that she's paddling plus the speed of the current is pushing her forward. So for these, the still speed plus the speed of the current is going to be the total speed. But if the kayaker is traveling back upstream, it's going to be harder, right? Because she's going against the current. So the current's actually going to slow her down. So the total speed going upstream is going to be the still speed minus the speed of the current. Speed of the current. So just take note for these types of problems, if you're going down speed or down river or you're going with the current, you're going to be going faster. And if you're going upstream, so you're going against the current, you're actually going to be going slower. Okay, so now we're ready to set up an equation so we can solve. So for this, we're going to be using our simple distance equals rate times time formula. And since we do know the total time that Mrs. GA is traveling or kayaking, we can take this formula and isolate t. So we have t equals d over r. So we can find a way to set up an equation that represents that total time that she's traveling. So for this, we're really just going to do the total time. So the total time equals the time upstream plus the time downstream. So our total time is going to be 6 hours. Now for the time upstream, we're going to do the distance, which is 5, divided by the rate. So for the rate, we have to figure out how to describe that. So since they ask in the equation, what is the average speed of the river's current? That's how we can define our variable. So we can say x equals the speed of the current, and we'll do that in miles per hour. So if she's going up speed, remember it's going to be the still speed minus the speed of the current. So the still speed, it says her average still speed is 3 miles per hour. So it's 3 minus x, so it's slowing her down, right? So the time upstream can be described with 5 over 3 minus x. And then the time downstream, well, it's the same distance. So the distance, and we have to do divided by the rate. So her rate going downstream is going to actually be 3 plus x. So that 3 miles per hour of her still speed plus the current speed, which is kind of pushing her forward and making her go faster. So 5 over 3 plus x. So you can see here that we have a rational equation that we're solving. So for this, we can solve it just like in the example 2. We can multiply every term by our LCD, which in this case is 3 minus x times 3 plus x. And let's see what we get. So here we get 6 times 3 minus x times 3 plus x. Here, 3 minus x cancels out, and we're left with 15 plus 5x. Here, 3 plus x cancels out, and we're left with 15 minus 5x. And we do need to multiply out what we see on the left. So we have 6 times 9, and then here these will cancel out. So we have plus 3x minus 3x, so then minus x squared equals 30. And then this is a quadratic, so here maybe I'll actually just divide both sides by 6 and then set it equal to 0. So we have 9 minus x squared equals 5. And then we can say that x squared equals 4. So x is equal to plus or minus 2. So looking at our excluded values from our original equation, we see that x cannot equal 3 or negative 3. And then if you look at the answers we got plus or minus 2. Now remember, x represents the speed of your current, and we can't have a negative speed, so that negative answer won't work since it's a word problem. So our only answer is going to be the positive 2. So that means that the speed of the current is 2 miles per hour. So remember, the negative, you can't have a negative speed. And again, we do need to check our excluded values, but 2 is not an excluded value, so we are good to go. All right, we're going to try one more problem together. So this says Mrs. GA can paint a room in 7 hours. When Mrs. GA and her sister Laura work together, they can paint the same room in 4 hours. Determine how long it would take Laura to paint the room by herself. So since they are asking for us to determine how long it would take for Laura to paint the room. That's how we can define the variable. Let's say x equals the hours it takes Laura to paint the room. So there's a few different ways we can set up these types of problems. I like to think of these problems in terms of how much of the job can they complete in 1 hour. So if you ask yourself, how much of the job will Mrs. G.A. complete in 1 hour? Well, if it takes her 7 hours to complete the job, in 1 hour, she's finished 1/7 of the job, okay? And then we're going to add that to the time it takes Laura. So if it takes Laura X hours to paint the room, in 1 hour, she's finished 1/X of the job. And then together, it takes them 4 hours to paint the room. So in 1 hour, they've completed 1/4 of the job. So here you can see that we have a rational equation. And we can solve this rational equation by simply multiplying both sides by the LCD, which would be 28x. So I'm going to go and multiply every term by 28x to clear our fractions. And that gives us 4x plus 28 equals 7x. And we know that x cannot equal 0 from our excluded values. So here we get 28 equals 3x, so x equals 28 thirds. Now, since it is a word problem, we're going to try to answer it, in a way that makes sense in terms of like if you were talking to someone and they ask, how long would it take you to do the job? We wouldn't say 28 thirds hours. So it might help for this one to rewrite this as 9 1/3. And even saying 9 1/3 hours, it doesn't make a whole lot of sense. It would be okay, but we know that 1/3 of an hour is 20 minutes. So we can say 9 hours and 20 minutes. So that would be how long it takes Laura to paint the room by herself. All right, that is all for today's video. Thank you so much for watching.